Hello guys, how are you? Hope you're doing great. Today we are going to have the last lesson in chapter 19. This is lesson 19.5 and is talking about angle relationships in circles, prepared by me, Ms. Salma Ahmed. Let's see the contents that we are going to talk about in these slides. We are going to have three theorems. Number one, the intersecting chords angle measure theorem. Number two, the tangent secant interior angle measure theorem. Number three, the tangent secant exterior angle measure theorem. Let's have the first theorem, the intersecting chords angle measure theorem. The intersecting chords angle measure theorem is saying if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So if I have this circle and I have AD and BC are chords intersect at point E, if I need to find the interior angle, which is, let's say 1, so this angle, I can find it by the rule or by the theorem that it say, get the sum of the two intercepted arcs between the chords and multiply it by half. So it will be measure of angle 1 is equal half measure of arc AB plus measure of arc CD. Let's see some applications. Find unknown measure of angle MPK. I need to find this angle which is in red. So I need to find this interior angle. So the theorem is saying, the intersecting chords angle measure theorem is saying that if I need to find the interior angle here, it will be the sum of the two arcs that formed by the two lines here. So here is a chord and here is a straight line. So I need to find half this arc plus this arc. It will be measure of angle MPK is equal half measure of arc MK plus measure of arc LN. I know MK, which is 61 degrees, and I know the measure of LN arc, which is 111. So I'm going to substitute half times 61 plus 111. By adding the two numbers, it will be half times 172. By using your calculator, you will find that it's 86 degrees. Let's have another one. Find unknown measure of arc PR. So now I need to find this arc, PR. And I know now, or the given here is the interior angle. But I can use the same theorem to find this arc. So measure of QTS is equal half this arc plus that arc. The theorem is saying so. So it will be equals half times arc, measure of arc QS times measure of arc PR. But I know this angle, which is QTS, so I'm going to substitute it by 58 degrees equals half, and QS, it's given also the arc, the measure of arc is 82 degrees. So I can substitute it. And the unknown, which is measure of arc PR, stays as it is. Now I'm going to multiply this 2 to the 58 because it is here in a divide. So I'm going to move it by times to the other side. So it will be 2 times 58, it gives me 116 equals 82 plus measure of arc PR. I'm going to move 82 to the other side by a negative sign. So it will be 116 minus 82, it gives me measure of arc PR. By subtracting these two numbers, so it will be 34. So arc, measure of arc PR, it will be 34 degrees. Let's have the second theorem, the tangent secant interior angle measure theorem. The tangent secant interior angle theorem is saying if a tangent and a secant or a chord, it means a tangent and secant or a tangent and a chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. Let's see if I have a circle and this is the secant and this is the tangent. So AB is a secant and BC is a tangent, and they met at the point of tangency, which is point B. The rule is saying, or the theorem is saying, that if I need to find this angle, which is the interior angle between the secant and the tangent here, it will be half that arc, which is the intercepted arc between the secant and the tangent, arc AB. So measure of ABC, angle ABC, is equal half this arc, which is the interior arc inside between the secant and the tangent, arc AB. Let's have some applications. Find each unknown measures. I need to find the following measures. I need to find measure of angle BCD, and I need to find the measure of arc ABC. So here I need to find this angle BCD, which is this acute angle, and I need to find the arc ABC. Okay, let's start by measure of angle BCD. By using this theorem, because BC is a secant and CD is a tangent, so I can find the interior angle between them. So it is tangent secant interior angle measure theorem is saying that measure of angle BCD is equal half that arc, which is arc BC, and it's given by 142. So I'm going to substitute. It will be half measure of arc BC, which is 142. By using your calculator, it will be 71 degrees. So this is the angle BCD. Now I need to find the arc ABC. To find this arc, I can find the measure of the angle ACD. So let's see, measure of arc ABC, by using the same theorem, that this is a chord and this is a tangent, I can find this angle, but it's given, which is 90. So measure of angle ACD is equals half the intercepted arc between the chord and the tangent, which is AC, or the arc ABC. Angle ACD is 90, as you see here, it's given. So it will be 90 equal half, and measure of arc ABC, I don't know. I need to find it. Sorry. By multiplying 2, or change the divide, the 2 in the division to the other side by multiplication. So 2 times 90, it gives me 180. So measure of arc ABC, this arc, it will be 180. Another example, your turn 1058. Find the measure of arc PN and measure of angle, measure of angle MNP. So I need to find these two unknowns. I need to find this arc PN, and I need to find MNP, the obtuse angle here. Let's start by measure of arc PN. So if I notice that this is a tangent, this line is tangent, and this is another line cut the circle. So I have an angle here, which is the interior angle between a tangent and a chord, or a secant, or whatever. So I know this. I can use the same theorem, tangent secant interior angle measure theorem, by that measure of angle P is equal half the included angle, the included arc, which is arc PN. So by substituting, a measure of angle P is 61 equals half measure of arc PN. Now I'm going to multiply this 2 to the other side, or move this by divide to the other side to be times. So it will be 61 times 2. It gives me 122 equals measure of arc PN. So this is the measure of that arc. Now I need to find measure of angle MNP, this obtuse angle, MNP. So this is a tangent and this is a secant. So I can find the interior angle between these two lines by using the same theorem, the tangent secant interior angle measure theorem. So measure of MNP, measure of angle MNP, is equal half of the intercepted arc between these two lines, which is arc NQP, this arc, which is 238 degrees. I'm going to substitute half times 238 by using your calculator. So measure of angle MNP equals 119 degrees. The third one, the tangent secant exterior angle measure theorem. You can use the difference in arc measures to find measures of angles formed by the tangents and secants intersecting outside a circle. Let's see the theorem, the tangent secant exterior angle measure theorem. If a tangent and a secant, or two tangents or two secants, intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measure of its intersected arcs. So this theorem, it's differ because I need to find the exterior angle, not the interior angle of the previous theorems. So if I need to find the exterior angle, for an angle which is outside of the circle, it will be half the difference of the intersected arcs now, not the sum. So here I have, this is a secant and this is a tangent. So if I need to find angle C, which is angle 1, I can say, according to the theorem, that measure of angle 1 is equal half the major arc, which is AD, minus, or the difference between these two arcs, AD and BD. So measure of angle 1 is equal half, measure the biggest arc minus the smaller arc. Or if I have tangent and tangent, and it forms an included angle, which is angle 2, I need to find it. It's the same idea. So measure of angle 2 is equal half that arc, the major arc here, it's EHG, minus measure of the minor arc, which is EG. So it will be measure of angle 2 is equal half measure of arc EHG minus measure of arc EG. Or if I have two secants and meet at a point L, which is outside, external, I need to find measure of angle L or measure of angle 3, which is exterior. So it will be the same. I'm going to use the same theorem, which is half that arc minus that arc, the biggest arc minus the smaller arc. So it will be half times arc, measure of arc JN minus measure of arc KM. Let's see some applications. Find the value of x. I need to find this x, which is the measure of arc KM. I know the exterior angle, and I know the angle which, I know the arc, which is the intercepted arc between these two secants. So by using the tangent secant exterior angle measure theorem, so measure of angle L is equal half the greater arc or the big arc minus the small arc. So it will be half times measure of arc Jn minus measure of arc Km. By substituting measure of angle L, which is 25, is equal measure of arc Jn, which is 83 degrees. So I'm going to substitute it, minus this arc, I don't know, but I will give it unknown x. So minus x. And now I'm going to multiply this 2 or move this 2 from division to multiplication to the other side. So it will be 2 times 25, it gives me 50, equals 83 minus x. Then I'm going to move 83 to the other side by a negative sign. So it will be 50 minus 83, it gives me negative 33, equal negative x. I can cancel the negative from both sides, so x equals 33. So this arc Km, the measure of arc Km is x, which is 33. Let's have another example. Find the value of x. Here I need to find x, and this x, which is the measure of the exterior angle. So I'm going to use the same theorem, the tangent secant exterior angle measure theorem, which it says that half, I need to find the exterior one, exterior angle. So it will be half the difference of the biggest arc minus the smaller arc. So it will be x equals half 238, which is the biggest one, minus, I need to find the smaller one, which is this one. So how can I get it? I don't have a number for it, so I can get it by 360, which is the full circle, minus the major arc, which is 238. So it will be 360 minus 238 to get this part in red. Okay? By using your calculator, it's very easy to get that x equals half 238 minus 360 minus 238, it gives me 122. Again, by using it to subtract the two numbers here, so it will be x equals half, and by subtracting it will be 160. So x equals 58. So the angle here is 58 degrees. Another example, find the value of x. Again, it's an exterior angle here, and I need to find it by using the same theorem, tangent secant exterior angle measure theorem. So it will be half the major arc minus the minor arc. So I'm going to apply it. X equals half 161 minus 67. So the difference between the two arcs. By using your calculator or mentally, it will be half times 94. Then you can find that x equals 47. Thank you very much, and I hope that you understood what we said. If you have any question, just contact me. It's very easy to contact by on the WhatsApp or whatever you want. Thank you very much. Hope you understood what we said.